So the mean is 3.21 televisions, and it also wants us to interpret that mean. And one way to interpret the mean of a variable is as an expectation. And that's pretty typical in statistics, is instead of calling it the mean, they'll just call it an expectation. So one way to interpret this would be to say in a randomly selected household, we expect to find on average 3.21 televisions. And I guess the key word that you'll want to use is expect, because that really is another way of interpreting the mean. In part D, they want us to find the standard deviation of x, so the standard deviation for the number of televisions. And standard deviation also has a particular formula. And so this formula is one where you take every x value, you subtract the mean, you square that difference, and then you multiply times the probability. So for this one, the mean was 3.21. The first x value is 0, so I'll do 0 minus 3.21, square that, times its probability, which was 0. The next x value is 1. So remember up here, the next x value is 1. Here's the probability. And so in the next term, you would do 1 minus the mean, square that, times its probability. The next number is 2. So you do 2 minus the mean, square that, times its probability. You would do that for all of them. I just put dot, 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 but all the way until you get to 9. 9 minus the mean, you square that, times its probability. You would take the square root of that whole thing. So I didn't write that, I should put square root. But you take the square root of this whole thing, and it comes out to 1.74 televisions. As a side note, I have notes on how you would calculate the mean and standard deviation on the graphing calculator. These are the steps on the Casio. These are the steps on the TI-83 and 84. In the future, I would like to make a video to show how you would do this on that video. But for now, those are the steps that you would take on the calculator. Back to the problem, in part E, they say, what's the probability that a randomly selected household has 3 televisions? So we can just go right to the table. 3 televisions is right here. The probability is 0.176. So there's nothing to calculate. You just go right to the table and look that up, 0.176. In part F, they want to know what's the probability that a household would have 3 or 4 televisions. 3 or 4, remember that word or means that you add. And we'll just 3 or 4, that's these two probabilities, we'll add them together. .176 plus 0.186. .362. And then part G, what's the probability that a randomly selected household would have no televisions? So 0 TVs. That probability is 0. 0. And then they ask, would you consider this to be an impossible event? And you might remember from a few weeks ago that an impossible event is when the probability is 0. That's just the term for impossible event. So to answer their question, we would say that yes, by definition, this is an impossible event for this sample of households. And that's important to specify because, of course, it really is not impossible. There are households in the world that have 0 TVs, so it wouldn't be probability of 0 for every household in the world. But for this sample, there were no households that happened to have 0 TVs. All households had a TV. Alright, so we'll do one more example from 6.1 that relates to the previous one. This is number 23, and the instructions are to do these four things. We'll come back to those instructions, but the topic is a game on smartphones called Paper Toss, and in the game the fans can give ratings for the game: 1 star, 2 star, 3 star, 4 star, 5 star ratings. And for this particular game, these were the frequencies of those ratings. So there were 2,752 1-star ratings, but the most were 5-star ratings, 10,518 5-star ratings. So with this table, the first thing that we'll want to do is construct a probability distribution for the random variable. So a probability distribution for the number of stars. I went ahead and started to draw out that table. Maybe I'll bring this down. So here's the table redrawn. I went ahead and added up these frequencies. The probabilities are just finding the relative frequencies. So the first one would be whatever this is, 2752 divided by the total, 23,718. And it ends up coming out to, let's see, it's down here, 0.116. And you would do the same for all of the others. The next one, when you do that, it comes out to 0.098. The next one comes out to 0.178, 0.165, and 0.443. So you just divide each of these by the total. In part B, the next thing that they want is for us to draw a probability histogram. Pretty similar to the last example that we did. Here's a fresh probability histogram. Label the axes, probability. The variable here is number of stars. And this is a probability histogram, so we'll go by all these probabilities. So the first one is 0.116. We'll make a bar for 1 star at 0.116. There. The next one was 0.098, so that's a little bit lower. It's about there. .178. A little bit higher. 0.165. A little bit lower. And the last one was 0.443. And that's the highest. That's about there. So that's our probability histogram. In part C, they ask for the mean, and then in part D, they ask for the standard deviation, and it's going to be the same formula as before. Here's the formula for the mean. Take those, take every x value times its probability. You do that for all of them, you add them up, and it comes out to 3.72. And the interpretation is going to be similar as before. So you would say something like in random for a randomly selected review, we expect average 3.72 stars. That's the expectation, that if we were to pick out some review at random, on average we would see around 3.72 stars. And the standard deviation, so here's the formula again. Put in all those numbers. I forgot to put the square root part, but you have to take the square root of whatever this all adds up to. It comes out to 1.41 stars. And like before, rather than using these formulas, you can work this out with the graphing calculators if you're comfortable doing that. Alright, we'll move on to another topic in 6.1.